Okay, so now that we've covered all the basics of trig, today we're going to look at some kind of advanced applications of trig. One of them that we're going to do looks like this. You know, the circles may or may not overlap like this. They don't have to, but for this example, I'm going to have the circles intersect. Pretend that's a tangent to the circle. And what I have is this circle here has a diameter of 1.8 inches. This circle here has a diameter of 1.1 inches. Nope. These are two intersecting circles. It's all two-dimensional for right now. So what I want to find, I want to find the length of that straight line. 2, I want to find the perimeter of this. Now in this case, since the circles overlap, obviously this cannot be a belt and pulley system because the two pulleys can't occupy the same space. But all you'd have to do is slide them apart a little further, and it could be a belt and pulley system. You'd be trying to calculate the length of that belt. Now, one piece of information we do have to know is I am going to give you that the center to center distance between these is, we're going to go 1.2 inches. So what do I know about all this stuff? What can I do? Well, remember we discussed this, that the toughest thing is to find the right triangles. And here's a classic example where the right triangle is kind of hidden on us. But we look for things that are right angles. One thing that we always look for when we're looking for right angles is, do we have horizontal and vertical dimensions? You know, the horizontal is always perpendicular to the vertical. In this case, we really don't have horizontal and vertical dimensions. The second thing we look for, which will apply here, is we look for tangents to circles. Because whenever there's a tangent to the circle, where's their right angle? Yeah, where the radius hits that tangent. So if I draw on a radius here, I know that's a right angle. I draw on a radius here, I know that's a right angle. Which tells me what about my two green lines? They should be parallel. Even though they're not drawn that way, they are parallel. I got them a little crooked there, but yeah, my two green lines must be parallel. What that tells me then, if they're parallel, I can draw a line across here that's perpendicular to both of them again. That line is parallel to this tangent line out here because of the right angles. What I've just formed is a rectangle. How big is this side of my rectangle? Yeah, 0.550 inches, half of my diameter, my radius. Which means this piece here, the opposite side of a rectangle must be the same, so this is 0.550. Which means this here must be, yeah, half of the point A is 0.9 minus 0.55 is 0.350. And now I have this length right here. What's that length? Well, that length is this is 0.350. This is 1.200. If I call this x, which is x, I mean this side of the rectangle and that side of the rectangle have to be the same length. So that really is the length x. It's going to be the square root of 1.2 squared minus 0.35 squared. Why is it minus? Yeah. Yeah, I have the hypotenuse and I'm subtracting back to one of the legs. Yes. So second square root 1.2 squared minus 0.35 squared. 1.148. So x, 1.148 inches. Now, if I only knew what this angle was and what that angle was, I could find the arcs of the circles. We'd be all done. Well, how can I find out what that angle is? Well, I know this is 90 degrees. I know that if I do the same thing over here, that'll be 90 degrees. And this angle will be the same, won't they? So I've got to find this angle right here. How do I find that angle? Well, I'm going to use the sides that we subtracted. This one, I could use it, but there's a little more calculation in that. There's a bigger chance that that one has an error in it. And we did have to round it off anyway. So I'm going to use the ones that I know are exact. So this would be the opposite side according to that angle, and this would be the hypotenuse, which means we're using the sine of an angle. Sine of that angle equals the opposite side, 0.350, over the hypotenuse, 1.200. So to solve it, I'm going to do the inverse sine. So my angle is second sine, 0.35 divided by 1.2. 16.96 degrees. That's this angle, which is this one. Now I got another one there, so I'm going to double it. Times 2 gives me 33.92 degrees. So what I have in that circle here, this is 33.92 degrees. And I have 90 degrees and 90 degrees. So this angle is going to be found by doing 360 minus 90, which is 180, minus the 33.92. So the 180 minus that answer. 146.08 is this angle. Now I'm going to pause. Any questions on how I got the 146.08? Any questions on where I got the 33.92? So this is 146.08 degrees. Now over here, this would be 180 degrees. Instead of subtracting the 32 point whatever, I have to add that to 180. So it's going to be 180 plus the 33.92, which is going to give me 213.92 degrees on the bigger circle. So this one is the 0.550 radius. Or on the bigger circle, the angle is 213.92, and that's on the 0.9 radius. So let's find the arcs. The arc on this one, well, the circumference is what? Actually 1.10 times pi, right? And then we're going to multiply that by the 146.08 over 360. Give us this arc. 1.1 times pi times 146.08 divided by 360. 1.402 inches. This one will be 1.8. Yep. Times pi times 213.92 over 360. 3.360 inches. Is that our time? So a belt or whatever going around the outside of this will be the 1.148 plus another 1.148 because there's a flat piece on the other side. 1.402, 3.360, which adds up to 7.058 inches, it looks like. Anybody have any questions on that one? Kind of.
1.18 is the diameter of
1.8 is the diameter of the big circle. 1.1 is the diameter of the little circle. And then it was from center to center, it was 1.2 inches. Other questions? What you think? Not too bad?
How do you figure second, like
this angle here? Well, over here, let me redraw this. Yep. Yeah, so we found this angle, right? We doubled it so that we got this whole thing. Right? Well, this and these are parallel, right? So this angle here must equal this angle here. So this one's just 360 minus that one. Or it's 180 plus this one. This one was 180. If I call this angle here angle A, it was 180 minus A. This one's 180 plus A. But either way, those two angles have to add up to 360 degrees because this one fits right in here. But yeah, once you find that angle and double it, you subtract it from 180 to get the angle on the other side. You add it to 180 to get the angle on one side. Any other questions? No. Number 26 was the same concept. Got the circles, put the centers in, draw them in. You got right angles here and here. You know this angle, this is going to be half of that whole angle. You know the radius. So then you can find this distance, and then from there you know the radius here. So you got two sides. You can find this angle, double it to get the big angle. I really think you guys want to try one of these. So I'm going to give you one to try. It's actually going to be on a worksheet that I'm going to hand out to you in just a second. Okay, I'm not expecting anybody to have answers yet for that one, but anybody have any questions on it? Anybody find X? What'd you get? 0.9395. Sounds reasonable. You get the perimeter yet, all the way around? Yeah, I'll give you that to do as part of your homework. Find the perimeter too. So on number one, yeah, that says X there, but also find the perimeter when you guys get to your homework. Okay, so now I want to do one similar to number 2 down there. And what we're starting out with is a half circle. So I'm going to give you this information. That is a half circle. And this half circle, for my example, has a radius of 32 inches. This over here is going to be 10 inches, and this is going to be a 1 to 3 slope, 1 to 3 taper over here. I want to find the area of this whole thing. Not drawn real well right now, but what I want to tell you is that this line here actually is tangent. Doesn't look like it, but we're going to make it a tangent. That's going to be true in the one on the worksheet as well, even though it's not drawn well. So we want to find this distance x, the whole bottom. And, so 1, find x. 2, find the area. 3, find the perimeter. Now, I didn't ask you to find the area on number 1 up there, just because of the overlap. But on a quiz someday, I might. That's a hint. Like maybe tomorrow. To find the area inside that. The two things. You have to subtract out the overlap of the circles, or you got to account for the overlap of the circles somehow. Not as hard as it looks. Or figure out how to not double count it. So anyway, we look at this, we know that's a right angle. We know that's a right angle. We got horizontal and vertical there. We know horizontal and vertical always form right angles with each other. We know a radius always forms a right angle with its tangent. If we knew some other angles, make life a lot easier on us. Yep. But we know those two angles have to add up to 180. Yeah, because that'd be 360 total for a parallelogram, for a four-sided figure. Not for quadrilateral, I should say, not parallelogram. I do know that over here, this angle comes from the 1 to 3 slope. So what I can do is I can draw a triangle like this. This is 1 and this is 3. This angle here would be the same as this angle. Well, this is the opposite leg, and this is the adjacent leg, which is tangent. So this is the inverse tangent of 1 over 3. Everybody see where that inverse tangent comes from? Opposite over adjacent is the tangent, so the inverse tangent will give us the angle. So second tangent of 1 divided by 3 is 18.43 degrees. Which really doesn't help much, but it does tell us that this 108.43 degrees. Why? Well, because that had to be a right angle there added to the 18.43. Which means this over here has to be 71.57 degrees. Now we have all the angles we need. Yep, these 4 angles, because the quadrilateral, those 4 angles have to add up to 360, and they do right now. Now that I have those angles, of course, I also now know this angle here is 108.43 degrees. So I can find this arc length, I can find that area, I can find all that happy crap. Over here, what we're really going to want to do is this. We're going to want to cut it like that. Once we cut it like that, it should tell us some more information. I'm going to let you guys play with that one in your homework, see what's going on there. The biggest thing is going to be to find this length x. Now, this red line that I put across here will help you find the area and perimeter once you know x. To find x, I will give you this hint. Draw this line straight down from that point of tangency. Find those two lengths. Then You can do some work there, knowing that angle. You will know this height because it'll be this overall height minus the 10, right? You blanked? Okay. Let's take a second here. So we have this triangle. (71.57 degrees). This is what, 32, did I say? Yeah, 32 inches. I'll call this little a, this down here little b. Little a, sine of 71.57 degrees will equal little a over 32. Cosine of 71.57 degrees will equal little b over 32. I'm going to cross multiply and divide. I get 30.359 for A. For B, I get 10.117. Now for this triangle here, I got the 18.43 degrees. Not yet. This is 18.43 degrees. Oh, you mean this side? Yeah, I'm going to subtract 10 from this, so this is 20.359. I'm just subtracting this 10 here. And now that I have that, I can find these two sides. And once I find those two sides, I've got x. I've actually got the slant as well. Does that help? To start. Have fun. Now, of course, your numbers are different on your worksheet, so you'll have to follow that process through again anyway. So, but you do have those two problems. Like I said, I didn't ask for the area on number 1, but you may want to find it.